All right, ladies and gentlemen, here we go again. Another round of some information. This is Mr. Doolin. Thank you for tuning in. Today we're going to take a look at net ionic equations, and this is just going to be a refresher. We will actually look at the difference between molecular equations, ionic equations, and net ionic equations. So I'm going to go ahead and label these molecular. And then we've got ionic, and then we've got net ionic, and we will discuss really just the differences, really the only thing we need to understand is why we use net ionic equations, I think is the big thing. And so what I'm going to do is I'm going to go ahead and write out the equation here, so you'll see a blank screen, and then I'm going to pause the video, and then I'm going to go back. All right, so there's my equation. You probably want to pause the video and write that down, but I'm going to go ahead and point out a couple of things. Number one, I want you to notice the state of matter on all of these molecules. So my molecular, this should be molecular, I just realized I misspelled that. My molecular equation should actually show everything as the molecules. I mean, that's why it's called the molecular equation. This is what you are used to seeing from pre-AP chemistry, your first year chemistry class. You're used to seeing everything written as the molecules. But now, based on the fact that we understand the dissociation and we know that aqueous equals dissolved in water, and now we understand the process of dissociation, BaCl2, if it's aqueous, does not exist actually as BaCl2. It's not existent as a molecule in solution. And so what I want to do is I actually want to break them down into their ions. And so everything that's aqueous, you can actually separate into its respective ions. And so I would go Ba, 2 plus 2 Cl minus. Because of the subscript 2 here, I end up with 2 Cl's down here, right? And then I've got 2 Na plus SO4 minus 2. Now, another thing, too, this is where your formula writing knowledge really comes handy, because all I'm doing is just undoing the formula, and I'm basing it on charges of the polyatomic, charges of the ions themselves, right, what group they're in. And so if you're kind of stuck as to what I'm doing here with the charges, you probably want to go back and review that. Now, another thing to notice is I did not break apart BaSO4. So barium sulfate, it's as a solid. It exists as that molecule, right? I can't break that apart. And then again, my sodium's over here, so that's a plus, and then plus 2 Cl minus. And then again, notice when I get into this ionic equation, I'm not writing aqueous anymore in any of these things. Because if it's an ion, it is understood to be in solution. I don't have to re-show that. All right? And so that's a big distinction too. If you see something as an ion, written as an ion in a chemical equation, it means it's in solution. It's already dissociated. All right? And so, but I can't dissociate the solids. And so now we want to go and check out a couple of things. And it's really very interesting. Notice I've got 2 NAs on the the product side and 2 NAs on the reactants, right? So 2 NAs in the reactants, 2 NAs in the products. It didn't do anything. It's exactly the same. So what we would call that is we would call Na a spectator ion. It spectated. It didn't take part in a reaction. It was there at the beginning, and it's there in the same way at the end. So also, if you check out your Cl's, I'll see that I've got 2 Cl's at the beginning, 2 Cl's at the end. I'm going to go ahead and cross out all my spectators. And so generally, I write my ionic equations so that I can actually find spectators. All right? And then the last thing I'm going to do is I'm actually going to come and find what actually reacted, right? And so I had Ba2 plus SO4 minus 2 to give me my barium sulfate solid, all right? And so a lot of times they're going to ask you why net ionic, right? Why are you writing a net ionic equation, or why does a net ionic equation show, or this is the best example or representation of this reaction? Well, net ionic equations only show what actually changed. It only shows what actually changed or what actually was involved in the reaction. And so that's why we use net ionic equations, because if you go back and take a look at the molecular, there's a whole bunch of stuff there that does not need to be there. My net ionic simplifies it all out and shows me only what is actually going to react. All right? Okay, I'm going to do another example with you. I'm going to go ahead and erase everything here and rewrite it. All right, and so here we go. I've got my molecular equation written. So again, if you're looking at having to do ionic, you're looking again, hey, what state of matter is it in? Remember, aqueous means it's dissolved, it's dissociated in solution. And so I'm going to go ahead and just this one, I'm going to break it out into its ions. So I've got H plus Cl minus plus Na plus OH minus, lots of pluses. I've got Na plus and Cl minus, and then here when I get to the water, again, I can't separate it. It's not aqueous, right? It's a liquid. It's a pure substance. And so again, I write out my ionic equation so that I can identify my spectators. And so again, I'm going to start here. My Na, I've got Na plus on both sides, so cross it out. I've got Cl minus on both sides. I'm going to cross it out. And then I see I've got H plus, so only my elements that are involved in the reaction are left. So I will go ahead and rewrite them in my ionic equation. That funny looking thing that you probably think is an E is how I draw my L's when I'm doing my states of matter. Okay, so that means liquid. And so here my net ionic equation, again, just shows the ions that are actually involved in the formation of something new that I can't separate, that's not dissociated or in its ion state in the water or in the solvent, whatever you've got. So there we go. So it's not too difficult. You take a molecular equation, everything that's aqueous, you split it into its ions, remove the spectators, and then you have your net ionic equation. And we use net ionic equations to show only those species that are involved in a reaction. Okay? All right, so hopefully that was clear. If you have any questions, be sure to get them down, and we will get them addressed in class and go over everything. We'll do some more practice with this, of course, but you feel free to look it up on the internet, find some practice if you want. And I will see you in class.